What is a polar coordinate system? Well, it's a system of magnitude and two angles. One azimuthal, phi, which you use when you try to look around yourself. And the other one is a polar angle. It's like when you try to rise your head up and lower it down. So it's connected to poles, like the poles of the earth. Using this notation, you may write a vector in this form. So lower letter A vector would look like 15, 30 degrees, 45. Interestingly, using those angles and the actual length of a vector, you can deduce the projections of the vector on the axes. It's quite interesting. Look, what if we want to find a x vector, a x projection? So first we need to go to the z-x plane. Yeah. So we will use this side. Now, is it adjacent or opposite to angle theta? Well, it's definitely adjacent. But what is adjacent by hypotenuse? What is the relation? Well, it's cosine. So you use cosine there. You multiply by cosine theta to go to z-x plane. But now you should really go to the actual x-axis. I mean this side. So next question I ask you is, what is the side? Is it adjacent to angle phi now, or is it like opposite to phi? Well, it's again adjacent, but now to phi. So you will use cosine phi. Bravo! If you multiply them, you go to x-axis. But what about other two? What about y and z? So ay would really uh, be simple to deduce. Look, we have this side, right? And I want to ask you, is it adjacent or opposite to theta? Well, we should probably first say that those are two equal because of, well, it's a parallelogram. Yeah. So is this side adjacent or opposite to theta? Well, it is definitely opposite. So we use sine, and this is it. We multiply r by sine theta, and voila, we have ay. Another projection will be az. Well, as in the previous case with ax, we should first go to the zx plane. So we will use this side. It means we will use cosine theta because of it's adjacent to theta. But the next step, we should use this side, right? Which will be practically equal to this side. Again, because of the parallelogram. So is this side, this, opposite or adjacent to phi? Well, it is definitely opposite. So we use sine phi, and multiplying them all together, r times cosine theta times sine phi, we get to the az projection. Isn't it fantastic? Have a great time and see ya.